Well, good morning, YouTube. I made some progress yesterday. I got a bunch of capacitors restuffed. Couple minor differences. All these capacitors, all four of them, are supposed to be 22K 1 ohm, 22K ohm 1 watt. One of them was a 12K. Only one band color is different. It's brown, red, orange on the 12K, and the 22K are red, red, orange. I also, though, this is a gold stripe, which means it's a 10% tolerance, I think, and the other ones are silver, which is 20. Possible Heathkit made a change later on and put an errata in where you change a component. However, I have no documentation of that. So I just went ahead and put in a 22K, thinking perhaps Heathkit put the wrong resistor in and the builder simply put it in because it's all they had on hand. And to think too that it's only off by one color band other than the gold, so it would be an easy mistake to make, and I want to make it as the original is. So that's those. That capacitor is restuffed. All these carbon, believe it or not, all the carbon resistors so far, every one of them, have been within 20% or less tolerance, which is good for old carbon resistors. And I haven't had to change any other than the one that was out of spec, the wrong one. Then coming around to the other side, I have replaced these. Now, as I mentioned, I think earlier, the three that I left here, yellow and unstuffed, restuffed, were all replacements. They were all Sprague and a couple pink ones, different brands. So I had to, I obviously didn't stuff the ones that had been replaced sometime in the 60s, I believe, judging from the type of capacitors they were. I did restuff these. There. One minor glitch, which I want to show you. Where the red lead is, from there to there was this capacitor, which this is why I restuffed them. And you know, I'm just a nerd, I admit it, and I like to do stuff like this, and even though it takes me more time, I don't care. This is going to be my own scope. I do take the time to restuff them. I know a lot of people don't bother. I think it's fun. It's part of the hobby to me. I think it's cool to preserve these. And if you look at this, it says vibrator condenser, which is different than the others, 0.01. Now, vibrators in the old days were often used in cars, where you had to produce high voltage for a radio off a DC 12-volt battery circuit, and this is 2000 volts, so I'm thinking vibrator probably is an indication of high voltage. I'm not familiar with it used in that application, but I thought that was kind of neat. Problem being, the part list does not call this a 2000 volt, and I don't have one because I ordered, of course, the standard yellow 630s that everybody buys. So I don't have a 2000 volt one to hand, and I'm going to have to order one of those. So I'm just going to keep that clip on there so I don't forget where it goes, and then continue working over here on the front. I have a bunch to finish here, and there's some on the bottom, and we'll continue with those, and we'll order up that missing one, and we'll see what other interesting things we find. Other than that, I have found this thing is built quite well, and it cleaned up very nicely, I have to say. So I'm happy with it. Oh, and this, I can't get it in the camera. I was going to mention too, the electrolytic, not surprisingly, was also changed. This is not the original can electrolytic. The original would have been two 10s and two 20s, and that's actually what I ordered. And what's in this can is 4 20s, 20, a 20, a 20, and a 20, all 450 volt. So when I'm going to cut this open and restuff it just to keep all the parts together, even though this is a replacement. But I actually have two 10s and two 20s, which is what the original had in it. So I'm pretty sure this is a replacement. Oh, and actually this brand, Sagamo, is made in the USA. That was the brand of two of these other capacitors I pulled out of here, and one of them was a Sprague, and those were all replacements. So this is a replacement. All the ones that are actually in this are this other brand, this International Condenser Corporation, Chicago, Illinois, made in the USA. Another reason I restuffed them. I think it's cool to have that on there, made in the USA. There's nothing made in our country anymore of this type of for this type of application, so fun to have that. Okay, I'll be back when I have some more to report. This is Tom. I also wanted to mention these capacitors here, the big ones, the big round ones. You may be wondering, where's the lead out of here? When I restuffed these, the leads on the yellow ones, which are in these, were too short to reach through the chassis to the other side to go to the terminal switch where they attach. So I cut a slit in the side, and you can sort of see the lead is coming out the back of these. It's how I made them long enough to fit. But they are actually in there, the yellow type, restuffed. And I thought I'd just mention too here on my videos, I'm going to go ahead and post this video and edit it up, and I also have another one to post and edit up of my condenser checker, my solar. And I also have a whole bunch of footage of my Kenwood. I've had problems with my Kenwood ongoing, and I'm going to eventually edit them and post them. But right now the Kenwood is not working. It's working in receive but not transmit, and it's going to become a troubleshooting video series. So I am going to get it working eventually. That is my plan. But these will be a little bit out of order. I'm going to get this one up, and then I'm going to get the solar one up, and then I'm going to start posting my Kenwood footage in the order that I shot it. And I also picked up this. This was I came in yesterday. It's a 1966 Philco Technical Institute electronic troubleshooting book, which I thought was kind of cool. And I'm a nurse. The front of this thing reminded me of an EKG readout, although it looks like the person's in VFib and needs to be shocked. So the cool thing about this is it's like one of these old detective books where you read through a section, you make a decision, and you go to another page. If you've made the right decision, it tells you. If you made the wrong decision, it tells you why, and you have to go back to a different section. And one part in it is isolate troubles to circuits, and it teaches you how to isolate problems to different sections of the circuit. And there's also sections in here I saw on signal tracing, which that's why I'm building the oscilloscope, is I want to do some signal tracing. So I thought this is kind of a neat looking book. So like here, which of the following best describes the action of the technician in performing the first troubleshooting step? And you pick one, and based on your answer you turn to that page, and then it tells you why you were right, why you were wrong, and then it takes you to another page. So I used to read these detective books when I was a kid that were like that. I thought that was kind of neat. And I didn't even know it was written that way when I bought it. I like the idea that it was a Philco troubleshooting book. And there's an oscilloscope readout, so it teaches you all about testing circuits and finding faults, and that's the whole point of an oscilloscope, is searching through the circuits to find what's going on. So that kind of goes along with what we're doing. So it's a lot of fun here. Okay, this is Tom, and I will say 73. I will be back with more videos at a later date once I get them edited up and posted. Have a great day. Hey guys, this is the YouTube update on the Heathkit O-8 Oscilloscope. This is the final capacitors to change. This is the inside of the dry electrolytic filter capacitor. This had been a replacement The original was 220s and 210s. So I cut this open, pulled it. Not my neatest work, but I have the 220s on that side and the 210s over here, and they will all fit nicely inside. The positive leads all coming out to the 4 lugs in the middle, and they all correlate with the schematic, the diamond, the nothing, which is a 10, as I recall, the half moon, which is a 20 that goes towards the transformer, which you'll see later, and the square, and then of course the grounding lugs. I just simply pulled the inside guts out of this, pulled out the old aluminum strip leads that went up into the old electrolytic, drilled holes next to the lugs, brought the wires out the bottom, and seated the first 3, which fit perfectly, and then of course the 4th one I had to put up so it can fit, you know, up inside the top of this, and this will fit nicely. I promise. I've already had it in here, even though I might not have a hard time getting it in off camera, but it fits. And then I'm simply going to tape it with aluminum tape and mark it on the outside what's inside it with a marker or something neatly, so any future restorer knows that it's been restuffed. And I like to put a little label on the bottom of everything I've done with my date of when it was restored, and write on there, you know, all capacitors restuffed, since I do restuff, and it's not always easy to know if you're dealing with original or old capacitors. This is the bottom of it, and there were 3 resistors across the bottom, and you'll see this all when I wire it back up, but the only good one was the 2 watt. That checks good. This one I broke getting it out, but I was actually able to probe the inside of that. I think I can see that, and that was high, and this one was almost double what it's supposed to be, so that's got to be replaced. And that's not unusual, I've found, with these. Any resistor that goes across some high voltage, like the high, you know, this is the filter cap for the power supply, they tend to see more stress and end up testing high. So that's a little update there. Once I get this all buttoned up and get it in the oscilloscope, I'll give you a quick tour of what I did on it, and then we'll power it up on camera, and hopefully it'll work. Hopefully. See you soon. This is Tom, 73. Good morning, friends on YouTube. This is Tom, K2BEW. And it was rather tight, but I did manage to get all the wires rehooked up to the bottom of the 4-can electrolytic, 4 capacitor, 1 can electrolytic. Had to replace 2 of the resistors, as I mentioned earlier, and that 15K actually measured pretty well. It was 16K or 15.9 or something, very close to what it was supposed to be. So what I had done previously, I don't know if I put this on there or not, I had made diagrams of everything and how the wires went, and of course double checked them against the manual. And again, as I mentioned, the nice thing about the Heathkit manual is you have a very detailed description of how everything gets wired. The only thing is, if you can see these wires are like all white, they're supposed to be colored, you know, a lot of them. And obviously over the years the coloring has gone right out of them, and you can barely tell what anything is anymore, including the transistor wires, which transformer rather wires, they are somewhat marked. You can see some colored lines left in them, but you can barely tell what they were. I don't know what causes the fading in some wires and others you don't, because I have an old Radiola 60 from 1920s 8 or 26, whatever it is. It's the very first super heterodyne that was mass produced by RCA, and that's going to be a future restoration prospect, and it has I've pulled the chassis out just to look at the bottom, and I will show that eventually. And it has these colored wires from the 1920s, and they're very bright. You can actually, it's in decent shape. I guess it depends on how it was stored. I think it probably has to do with moisture more than anything. The moisture destroying the coloring. This one was in a moist environment in a shed at one time, this thing. And I think the radiola was not, fortunately. I think moisture is probably the biggest killer of electronics. So everything's wired up. When I'm back on camera again, we're going to have this thing hooked up and fired up. The only thing I didn't do, I was thinking of checking this oil-filled capacitor. It's a 1 microfarad oil-filled cap, a large high voltage one. And I was thinking about testing it, but I think I'm just going to fire it up and take a chance. We'll see what happens. If I have any problems, that's the only capacitor that didn't get changed, of course, and I'm thinking being an oil-filled one, it should be okay, hopefully, because it's such a high voltage one. I imagine I could find some modern equivalent, but I'd prefer to use the original. And it's probably okay, I'm thinking, just because of the type of capacitor it is, but we'll see. So when I come back, we're going to be wired up. This will be in the cabinet, and we're going to try to turn it on and see what happens. Give it the old smoke test. Although I'm going to have it on the dim bulb tester too. Be back. This is Tom. Good morning, YouTube. I decided to check the oil-filled capacitor. I looked through the literature and I cannot find a lot of information on this thing other than I know it's 1 microfarad and it's oil-filled and it's a high voltage cap. It doesn't even indicate anywhere in any of the Heathkit information what voltage it's for. And the side of it has some markings, like a reference ROL 150 130/11. Is that 130 volts? That's not high voltage. Not sure what it is. I'm thinking it's, at least 500 volts, maybe 1,000. Anyhow, I decided to hook it up to the capacitor checker anyway, because my feeling was this capacitor hasn't probably been charged in years, so even if it's good or bad or what have you, it's not a bad idea to charge it up. You can actually use these capacitor checkers to reform capacitors over short periods of time, because they do put voltage through them. Oh, we did a little renovating. I found a label. By the way, if anybody needs a label for one of these, I pulled this off the Antique Radio Forum. Go to the Antique Radio Forum, use their search engine, and search for solar capacitor analyzer, and there's a big long thread, and this JPEG is posted there. You can pull it right off their website and print it on my printer. That's all I did. It's regular printer paper. I stuck it on there with contact cement, and then I put sanding sealer over it. It's like a shellac, so it would kind of discolor it a little, make it look older. Although it did have that yellow color already right off of the website when I printed it, which was kind of nice. So anyhow, here we go. This is hooked up, and we're hooked up to condenser. We're hooked up to the short section, and we're going to slowly go through these. I'm going to turn the light down a little, put some voltage through this thing and see if we get some leakage indications. Nothing there. That's good. I'm just checking the connection. Got one little flash there, which is fine. It says no glow or leakage neon or periodic flashing not exceeding 1 per second is satisfactory. Shorted. A steady bright glow which does not diminish. Open. An open condenser is detected on the capacity check. Shorted, open, blah, blah, blah. Anyhow, if it flashes quickly, or the faster it flashes, the more leaky it is. And if it stays on continuously, it's really leaky or even open. So we have it on the setting 2 so far, which is giving us about 1 to 200 working volts. Okay, setting 3. That one flashed a second and it went off. That's 1, 2, 3, 2 to 300 working volts. Okay. And this is supposed to be a high power capacitor. As I said, I don't know the rating of it, but it's got to be high. There's a 2000 volts capacitor in this thing. There's a film cap down in there, and this has got to be more than that. So I'm not concerned about putting voltage into this. Actually, I want to kind of form it up a little. One little flash is fine. That's normal. Okay, let's go up to setting 4. Setting 4 is going to be 3 to 400 volts. One flash and it went right off. That's good. That's very good. And this will be 4 to 500 volts. One little flash and it went right off. I figured it was probably good. I think these old oil-filled ones are usually decent capacitors. As I think I shared, I think this is probably a surplus military capacitor. It is painted olive drab green. So now let's see what it tests at in the range. Let me look. I gotta look here for a second. The red range should give me 1 picofarad. So let's go around to red and let's check for the eye deflection. It's opening, it's opening. Highest deflection right about there. And look at that. Very nice. It's you can't see it, it's under the thing. There's the 1 picofarad. It's dead on. Dead on. By the way, I did a little bit on the restoration on this thing. I had shared with you in the past that I had 2 electrolytics inside this that I changed, and one I ended up putting an 8 and one a 10. They're supposed to both be 8s because I broke a lead off an 8. I bought 2 8s that are matched, and they are both Vichy good quality caps. So there are now 2 8 microfarads, which I hopefully will make this more accurate. And additionally, I had the 2 ceramic capacitors in parallel, which gave me 0.02 in there. I changed those out to a 0.02 film cap, which actually is what is called for in some of the other models of this capacitor analyzer. So that could account for why this is so accurate now, and it looks pretty darn accurate now. That's 1 microfarad right on. That's great. Well, as good as you can see this on the camera, I can see it better than I think it's showing up on the camera. But when the eyes open all the way, that's your reading, and it's right on 1. And we have no shorts. One more check of the shorting, and that'll give me a chance to run a little voltage through this for a couple minutes. See, I get a nice little flash, which is fine, but it goes off. And now we wait. And I think, oh, that's 4. Let's go up to 5. Interesting. Flash at 2. I wonder if I have good connection there. Flash. That's 5. 500 volts. Okay. I'm going to leave it on there for a couple minutes. It says to leave it on up to 5 minutes to watch for. Now there's 1 little flash, and that's fine. As I said, no glow in the neon light or periodic flashing not exceeding 1 a second. That's definitely less than 1 a second. An occasional flash actually indicates that I have a good continuity through it, and it's working, and it's not too leaky. So everything's replaced in this. That is working. I'm going to reconnect it. I'm going to put the CRT in it, and I'll be back turning on the oscilloscope. This is Tom.